Apply Kruskal's algorithm to obtain a minimum spanning tree for the network shown and calculate its length. So what we do firstly is we start off by choosing the edge with the least weight. And if there is more than one, it doesn't matter which one you choose. Let's look at our graph over here. So on the graph, you can see that the weights are marked in, and the smallest one is 2. And it happens to be that we've got exactly 2 edges that are of weight 2. So we can start with either one, it doesn't matter which one. So I'll start with this one over here, so A to B. And what we do is we kind of just add these edges into our graph one at a time, and as long as it doesn't form a cycle basically. So for the next one, we've got this one which we're going to add in as well. So there's 2 and 2. And then we go and start looking at what's the next edge with the minimum weight. So once we've used the 2 and the 2, we've got the 3 over here that we could use. So we'll mark that one in over there. So this one would be from C to D. Okay, there's that one. And then after 3, is there a 4? There's no 4. There's a 5 over here. So we can use this one or that one as long as it doesn't form a cycle. So we'll put this in. And that's next one over there. Can we put in the next 5 over here? So let's have a look. Does it form a cycle? And it doesn't. So if I mark that in, you can see this is still not a cycle, so I can keep going. 6 is the next length. Okay, so there's no more 5s, so I now need to move on to 6. If I add in the 6 over here, you can see that I formed this cycle or this loop. So I don't want to add that. And same with this one over here. But furthermore, if you have a look at what we have now, we've actually got a minimum spanning tree, because if you look at what we have, we've got 1, 2, 3, 4, 5, 6. All 6 vertices are connected now. So because they're all connected and there's no cycles here, basically we've got a minimum spanning tree here. So the minimum spanning tree that's outlined in red over here, and the length we can calculate. So it's basically 2 plus 5 plus 3 plus 5 plus 2. So I'm just going along over here, and if you calculate that, that works out to be 17. So the minimum spanning tree has a length of 17.